negative selected values of a polynomial function, which the following must be true. So I think the best way to go about doing this is simply to do a rough sketch. Okay, so I've created a graph. I'm going by ones on the x-axis and going by intervals of 2 just so I can fit this on. I'm going to go all the way out to -3 and going up to approximately 18. So that would be approximately 18. I'm going to -2 and up to 20, so it's in this shape. -1 is going to be at 12, at 0, 0, so it's making this shape just straight down there. At 1, you're at -10, so all the way down here. At 2, you're at -12, a little bit lower, and at 3, we're at 0. Alright, so let's look at the basic shape of this polynomial. This transition downward on the left tells me that I believe the pattern is going to look like this, and it's going to look like this, very cubic-like. So I believe there are 3 distinct zeros. So exactly 2, no. And how do I know this again? Because I can see that the output value at -3 is less than the output value at -2. And so we can see that on this part we have this portion going to the left is going down. Okay, it has a global maximum of 20. So is the highest point 20? No, that'd be a relative or a local high point. How do I know it's not global? Because it insinuates this is going up and there will be no global max or minimum on this polynomial function. Alright, the next up is this function is concave down on the interval from 0 to 3. So here's 0 to 3. Think about this. This is concave down. But here there's a turning point, and here this looks like concave up as it's increasing. I don't think that's right. We have a local minimum on the interval from 0 to 3. That is true. So between x equals 0 to 3, there is a local or a relative minimum. Correct answer is D.